Hey everybody, I want to go over this problem that we had worked on in class and make sure that we're feeling awesome about all aspects of this check. So, starting off, a 20 ohm hot glue gun has 6 amps running through it. So, first thing we gotta identify is what we know here. This 6 amps and this 20 ohms, the 6 amps is a current. And the 20 ohms is a resistance. Gotta know your units. That's a good thing to review so we can recognize what the problem is telling us and what we need to find. In this case, the voltage drop, that delta V. Well, seeing I, R, and delta V written out like that sure leads me towards Ohm's law, that the voltage difference across a resistor is equal to its current. And then, or divided by its resistance. So that is... I can rearrange that and say that delta V equals I times R, or that must be 120 volts. That makes sense, the standard voltage of a regular outlet that you would plug into. Now we're asked for the power. P equals what? So I have a lot of different options here for power, and I could say I times delta V squared over R, or I squared times R. And I have, any one of them would work. I'll use I delta V in this case. And that's 6 amps multiplied by 120 volts. And that gives me 700 and... I guess it's not even worth it to... not bust out my calculator here. So 6 times 120, 720 watts for power. Great. Determine the equivalent resistance of the circuit below. Show all steps. Awesome. This circuit is complex with lots of series and parallel, just multiple resistors. So I am going to break it down. The first thing I see is this 60 and this 20. I'm going to not do anything with this 10 ohm, but I can break a parallel and say it has an equivalent resistance. And I can say 1 over R equivalent equals 1 over R1 plus 1 over R2. Or in this case, 1 over R equivalent equals 1 over 60 ohms plus 1 over 20 ohms. And I guess I could common denominator that, or calculator time. 1 over 60 plus 1 over 20. That 0.066666667 is the most popular wrong answer, because you have to remember to inverse that to be left with the equivalent resistance is 15 ohms. Those two combined, since they are in series, they will just add together. 25 ohms for the equivalent resistance. Great. Flipping over, I see the circuit below shows a 10 volt battery connected to a 30 and 90 ohm resistor as shown, and as shown is in series. Determine the current and voltage drops across each resistor. So the first thing I have to do is I have to simplify it. It can be tempting to look at this and say, oh, I'll use Ohm's law because I'm trying to find current and voltage drops. Problem is, I don't know the current or the voltage drops across these, so Ohm's law gives us some trouble because that's two unknowns. This is the voltage drop for the whole circuit, the battery. It's the voltage gain, and we're going to lose 10 volts across all of them. But in order to make sense of this, I need to know that this simplifies to 120 ohms because these are series circuits. Now I can start to do some stuff with this. This is a 10 volt drop. Due to the loop rule that says all the voltage that I gain, I have to lose in a circuit. And thus, the current must be 10 volts over 120 ohms equals I equals a fraction, 10 divided by 120, or a decimal, 0.0833 amps. Now we found out everything there is to know in this circuit. One resistor, 1 voltage drop, 1 current. And that's great. And that's got to be the current everywhere in here and everywhere in here because these are in series. And if I found the current at one spot in a series circuit, I found the current in every spot in it. So both of these have 0.833 amps or 0.0833 amps or 1/12 amps. Now to find the voltage drop, now it's time for Ohm's law. Delta V equals I times R, and 0.083333 times 30 gives me 2.4999999, or I could safely say 2.5 volts for that voltage drop. Now, that means I'll use Ohm's law again, but I can already predict what the voltage drop is going to be. The current, 0.08333333 times 90, gives me 7.5 volts. And that makes sense because the full drop has to be 10 volts. And here we see that this is a quarter of the total resistance in the circuit. It's 30 ohms out of 120. So it takes a quarter of the volts, a quarter of the potential energy, and turns it into heat. 3/4 of the potential energy is lost across the 90 ohm resistor, which is why we get 7.5 out of the full 10 volts, and that seems reasonable. Lastly, we have this circuit, and we're asked to find the reading in the blank ammeter and the blank voltmeter. Well, first we have to identify that this is in fact a voltmeter connected in parallel. A real voltmeter that we'll use in class has little knobs that come out like that, and they go over top of a resistor. In class, our ammeters kind of look like this. And they go in series right next to a resistor. So that's the ammeter right here. Well, first we can do the blank ammeter and see that there's 1.2 amps and 1.2 amps and 1.2 amps and 1.2 amps all throughout this section right here. 1.2, 1.2, 1.2, 1.2, 1.2, 1.2, 1.2. And it all flows into here following the circuit. And then there's a split. Some of the current goes this way and some of the current goes this way, just like you and your friends walking down the hallway. But we know 0.4 amps goes this way, and you cannot destroy students walking down the hallway. You cannot create students walking down the hallway. You cannot destroy current as it goes through a branch, and you cannot create current as it goes through a branch. Charge has to be conserved. So if we had 1.2 in the beginning and it splits up and 0.4 goes down here, then 0.8 has to go up here. I'll say 0.80 amps. In a few sentences, explain how you arrived at your answer. Well, those sentences could talk about the junction rule. Or you could call it the current law. Those aren't sentences, those are just words. But you can say, hey, the current in to any junction has to equal the current out. And you could say that you can't destroy or create current. Exactly what I was talking about. Destroy or create current. And I'd want to see more here about that whole, if there are 1.2 amps, it has to split up. And then those amps come back here and again rejoin to make the full 1.2 amps again. What's the reading in the blank voltmeter? A few different ways to figure out this one. Ohm's law works to say delta V equals I times R, or you could use the voltage law and realize that all your drops have to add up to 5.2 volts. So 1.2 times 3 ohms gives me 3.6 volts. And that is the drop across to that one. You can also make sense of it if you find out the voltage drop here must be 1.6 volts. And you can say, look, if there's a 1.6 volt drop here, and you only gain 5.2, then you must drop 3.6 volts to get back down to 0. Because a 3.6 volt drop plus a 1.6 volt drop gives you that 5.2 volt gain. But Ohm's law, always effective, and both work. And that's the thing with circuits. You can always check your work to see how you are progressing. Good stuff on this check. Watch the video again, print out a blank copy, and go through these problems over and over until you are feeling 100% good. Thank you.